Hallo, it's dumplet here. Here's an item on geometry. We have a quarter circle on the left here, so refer to the figure. We have the radius to be 6, and we have some angles here to be labeled. We're asked to get the area of the shaded region. Credits to Jonathan Key for this item. As usual, pause this video if you'd like to give this item a try. But if you're done, let us dive into the solution. Alright, so upon primary inspection of this figure, at least in the shaded area that we're trying to get, it's not really a shape that we can describe. It's the three sides, I guess, of the region that we're going to get the area of. They're straight lines, and we have a circular arc here. So maybe we have to do some addition, subtraction of areas. That's pretty much to be expected. We can kind of imagine it like, okay, I might take like the area of a sector, subtract this triangle, and then subtract this one. That is possible, but here we're just going to start with some small observations. We're going to take care of the more complex calculations later. So let us try to label some points first so I can refer to them more easily. And alright, we have some angles, and well, I assume we have a lot of isosceles triangles here because, well, AB, BD, and BE, they're all the radii of the same quarter circle. So we label this as like this, and we can try to chase some angles here because, well, triangle BDE is an isosceles triangle. The vertex angle is 40, so 180 minus 40, that's going to be the sum of these two. And then we're going to divide it by 2. Now this is going to be 140 divided by 2, so that's 70. So this angle here, angle BDE, it's going to be 70 degrees, and angle BED, it's going to be 70 degrees as well. All right, pretty interesting. Well, AC is parallel to DE because, well, we have the 270 degrees here. But what's more important here is that, well, the 30 plus 40 here, it gives 70. So this angle over here is 70 degrees as well. Well, so ABC is an isosceles triangle because two of its angles are 70. Now, what's more interesting is that, well, this is the same case for triangle BDE. The two base angles are 70 degrees. Now, I'm just going to put the 40 degrees here because, well, now that we know that they're technically similar triangles, then we can even move on further because we know that ABC is isosceles now. We know that AB must be equal to AC. And there we have it. We now have a congruence, actually, that triangles ABC, so I'm going to write down triangle ABC, which is isosceles, and this is congruent to triangle BDE. Because, well, they're both isosceles, and then the pair of sides must be the same in the isosceles triangle. They have the same lengths. They're all 6 centimeters, essentially. So with this, I'm going to propose that we can kind of rewrite this shaded region, or redraw this shaded region, reposition the pieces here into this. Now, why can I do that? Now, take note, we have this congruence based from the previous slide. Now, triangle ABC and triangle BDE, based on the figure, they have a common region here. This is their common region. So this is their common region, and that is the reason why we can say that this region over here, let's call this region 1, this region over here, plus this yellow region, that's going to be the area of triangle BDE. But that's also the same as saying this yellow region plus this region, which is going to make up triangle ABC. Now, since they're congruent, they must be the same area, and that's why we can say that region 1 and region 2 will have the same area. Now, why is this important? It's because we get to reposition the pieces, and, well, the shaded region at the start is essentially equal to the area of this, well, now it's a circular sector. And it's pretty nice. We have the angles, so we can immediately use the area for a sector. So let's just say the sector is area S. So the formula for the sector is 1/2 times the square of the radius times the angle theta. This will be in radians though, so we have to convert it into radians. But we already have the radius. It's given to be 6 centimeters. So 1/2 times 6 squared times, well, 30 degrees, that's the angle here. we just have to divide it, we just have to multiply it by pi over 180. So 30 times pi over 180, that's going to give us pi over 6, so we put it here. Angle is pi over 6, and we just simplify the result. 1/2 times 6 squared times pi over 6, we can cancel one of the 6's here. So 1/2 of 6 times pi, that's going to give us the final answer of 3 pi. So the area of the shaded region at the start, which we may not really have a nice description for it, that is equal to 3 pi. Hopefully you guys learned something new from this video, and I'll see you in the next one. Bye bye!